Hi, welcome to the high bay of the free electron laser group at the physics department of UCSB. My name's Travis, and I'm a design engineer working on this project right now. I'm going to show you around what we do here. So our purpose here is we're really winding a prototype of the undulator that the free electron laser group wants to install in their free electron laser. And this right here is the prototype of the prototype. What this was meant for was to show the basic geometry and the features that we have to wind on for the actual coil form. This piece is actually now being made out of aluminum for the actual prototype. So as you can see, there's two different sections of the prototype. There's the uniform section right here that is all uniform, nothing changes, it's just consistent double helix. And then once you get down here, there's the tapered section, which allows for wires to be pulled back. The pullbacks, or the turnarounds, allow us to taper the magnetic field within the undulator, thus aiming the laser as it exits the undulator. How the turnarounds work is that the wires are wound within this groove right here, and as it goes and reaches this turnaround point, one wire at a time comes here, wraps around this radius right here, and it comes back on the other helix. Each turnaround is going to have two wires that pull back. Thus, by the end of the 20 turnarounds here, there'll be no more wires right here. And this is how everything turns around. This piece of paper right here represents a viewport that goes into the actual tube that the undulator wraps around. This viewport allows us to view the laser angle and make sure everything's lined up correctly within the tube. The undulator is going to be made out of all pieces, sections, are going to be made out of two halves, a top and a bottom half divided at the split line, and they'll be clamped together with shoulder bolts, like so. This is the spool carriage of the winding rig we are building to wind the undulator. It consists of different features and different components to account for different features we must meet for the winding. This here is the winding twist prevention system, which stops the wire from twisting with these 4 adjacent rollers as so. This carriage also has to be able to slide to wind the entire undulator and flip when it gets to a turnaround. This motor right here is to keep tension on the wire, because the wire has to be wound at a specific tension of roughly 60 to 80 pounds of tension. This is a festoon to hold all the cables for our control systems that runs everything here. And there's another little baby motor here that moves the spool back and forth to keep the wire aligned with the wire prevention system. So this is the cone head rotational collar and the custom pillow block that we built for it. The rotational collar allows us to rotate the coil form instead of the tube that we're winding on. The tube only has a 30 thou wall, and we didn't really want to rotate that and put too much torque on it because we could deform the tube. So we decided to come up with this complex device right here. The geometry is pretty intricate because we were going from a 2-inch diameter to a roughly 4-inch diameter to allow for the structure inside. The coil form itself is 2 inches in diameter, 2.14 to be exact. And the flange that attaches onto the end of the winding tube to allow for vacuum testing and vacuum sealing is roughly 3.756 inches in diameter. So we built this and designed this to account for that and allow us to wind this without too many issues. On the back of this, there's a sprocket which attaches to another sprocket that's run by a central motor that turns both this pillow block, this rotational collar, and the mirrored one on the other side. So now I'm going to show you the winding support system of our winding rig for the undulator. As you can see over here, we have two different colored rollers, orange and white. The orange rollers represent the claw or clamp rollers that actually actuate out of the way when we need them to. The white rollers are static rollers, and they're basically there to have a little more support holding up the undulator when we set this in place, and from the back too. Let's talk about these orange rollers. These orange rollers are on the top and bottom, so two sets, because the wire will be wound on both the top and the bottom of the undulator. This is because when you hit the turnaround, you're going to have to flip the spool, and thus flipping the side of which the undulator is being wound from. So as the spool carriage moves axially along the undulator, these rollers will have to be removed so that the wire doesn't get in the way. Now let's move on to the white rollers, the static rollers. Like I said earlier, they're basically there to support the undulator, to make sure nothing really bad happens to them. It doesn't sag or deform the shape, since it is only a 2-inch diameter by 1.4 meter long piece of aluminum / steel, a noodle. Okay? So if we come hither, I can show you how these clamps actually work. So if you look yonder, you can actually see how the spool carriage right now is representing how the winding operation will work. As the wire is being wound on top of the undulator, this roller will be pulled out of the way, like I just did, and it can wind along this path right here. Once the wires pass this roller, you're going to reapply it and lift up the next one. This allows for the undulator to be supported as much as possible while still not being in the way of the wire. So, thanks for watching this video about the undulator prototype and its winding rig.